Hey class, this is the first of a several videos that we'll be looking at about the normal distribution. Okay, so this particular video, we're solving normal distribution problems, just individual values. So there's no central limit theorem, just like we've been doing all week, but we're using technology. Okay, so I've gone to two different textbooks, some of my older textbooks that were on my shelf, pulled off a number of problems that we'll begin to solve. So let's get started, okay? First thing, here's the question we're very familiar with. They're kind of like the ones you saw from the handouts that I gave you. So the statement is, the random variable x has a normal distribution with mean of 200, standard deviation of 25. Find the probability that x is between 160 and 120. Okay? So I'm actually going to write on this slide so you can see how you would set it up. So I'll go back here. Okay. And so the answer to the first one, and in fact I'll just call this one A, B, and C. Okay, so this is A, this is B, if I can get to B, and this one is C. Okay? So first of all, the notation. If I want the probability that x is between 160 and 220, it's probability that 160 is less than x, which is less than 220. Some textbooks you'll see less than or equal to, less than or equal to. It doesn't really make a difference because, as we know, the probability of a single value is 0 underneath the curve. Okay? This is equal to. Now, we have a normal distribution. It's not standard normal. So I need to do norm dist. The first value is what I'm interested in, which is 220. Second value is the mean, which is 200. And the standard deviation is 25. And true. This will give me the amount that's less than 220. And I have to subtract off the amount that's less than 160. So I'll set it up again. 160, 220, 25, true. Equals. I don't know what this equals, but what we can do is copy the formula. And I have Excel open already, so I'll just make it large. Alright, and paste it. Okay, so Q1. Okay, and so A, you're looking at that. Wow, that's really big. But A is you're looking at that formula. Okay? Which is equal to, alright, if I put, so I'll leave that up there actually. And I'll copy it again. Copy, paste. So you'll see what we looked at. If I put an equal sign in front of this, you'll see what the answer is. If you don't get an error first. Norm dist 20 true minus norm dist 20 true. And it doesn't like it for some reason. What is the problem here? No, I'm not even sure what they don't like here. Let's try this. Norm dist of 220, 200, 25, true. That they like just fine. And I'll do the same thing for the other one. Maybe I'm just being difficult today. Ah! I see one problem already. The distribution mean is 200, not 220. So I'm actually glad we had an error there. Okay. So this number here needs to be 200 as well. Okay. So you have norm dist 220, 220 true, norm dist 160, 225 true, and then I would just subtract the 2. So equals this minus this, which is this number. I'll knock off 2 decimal places and give you 7333. Now this actually should be a 4. 7334. Alright, so then I would highlight this and go back to PowerPoint and call that 7334. And I'll change that to make that a 0. Okay? So that's the first one. Second one gets set up very similar, except I want just the area that's greater than 240. Now we know that the norm's dist only looks at what's to the left, so I need to do 1 minus this. So x, which is greater than 240, equals norm dist. Alright, norm dist 240, 200, 25, true. This is the area that's less than it, so then I need to do 1 minus this. And this will equal something. Let's find out what it is over here. For some reason, I don't think it likes it when I copy and paste it. But let's see if I have the same error this time. So we'll shrink that again back to 16. And I'll paste it again here. Shrink it back to 16. Put an equal sign in front of it. Enter. Now that one I like just fine. Okay. So the answer is 0548. So that means that when you go back to the PowerPoint, I have 0.0548. So there's a 5.5% chance that the probability is greater than 240. And the last one is very similar, less than 150. Probability of x less than 150. I don't need the 1 minus. Excuse me, norm dist. I have 150 here, I have 200 here, I have 25 here, I have true equals something. Okay, so I'll take this, copy, back to Excel, C, paste it here, drop these two to 16. And take away the equal sign from both of them. And from this one. But I will put the equal sign back in front of this one. Equals 0.0228, which it should give me if I get rid of, there we go, 0.0228. So the answer to this question is 0.0228. Okay. So what's the probability that x is between 160 and 220? Because the middle is 50%, and the norm dist actually gives you everything to the left, regardless of the middle or not. You can take the area to the left of 220, subtract off the area to the left of 160, and you get what's in the middle. For the second one, the key there is to know you have to do 1 minus norm's dist, and you'll get the answer of 5.5%. And for the last one, you can read off norm's dist exactly. Okay, so that's question number 1. I'll get rid of these two. And actually, I can put the answers. I don't even need this right now because I have the answers there. Okay, so that's question 1. Okay, let's look at question 2. Question 2 says there's a monitor that's been manufactured. They tell us we have a normal distribution with an average life of 1500, standard deviation of 15,000 with a standard deviation of 2000. And so if we select the one at random, find these probabilities. Pretty much the same setup we had before, except this time I'm actually going to put in some values for mean and standard deviation, so I can click it. We still have, I'll increase it again, we still have A, B, and C, okay? Except I want to make note of the mean and standard deviation, so I can just click it. Mean, they told me, was 15,000. Standard deviation was 2,000. If I'm not mistaken. I could be wrong. Let me make sure. 15,000, 2,000. Okay? So they want the probability that the lifespan of the monitor is less than 12,000 hours. Okay? So what I'm going to do for this question is get rid of these two, and I'll put the answer underneath it. Okay? So in order to get the area that's less than 12,000, I'm just reading off Norm's dist, right? So it's equal norm dist. The number is 12,000. The mean is 15,000. The standard deviation is 2,000. It's true. And whatever that gives me is the answer. Okay, so let's do that. If I come back here, equals norm dist. My number was 12,000. 15,000 was the mean. Standard deviation was 2,000. And true. And so when I do that, I get 0668. So the answer to this first question is 0.668. 0.0668, I think. 0668, correct. So there you go. So there's about a 6.7% chance of having it last less than 12,000 hours. The next question, what about if it's more than 18,000 hours? Again, I'm going to get rid of these two so we have space to put the answer. The answer, we know that we need norm dist because we don't have the standard normal distribution. Okay? You can have, what can you have? 18,000. Whoops, don't put the commas in because it will make it mess up. My mean is 15,000. My standard deviation is 2,000. And I'm saying true. This gives me what's less than it. So I have to do a 1 minus. And that will give me my answer that I'm looking for, which I don't know yet. So I'm going back here. 18,000 is the number we're interested in. Equals 1 minus norm dist. 18,000. This number, true. Enter 0668. Wait a second. Does that make sense? I have a number that is 18,000 or more, and I have a number that's 12,000 or less. Should I have the same number? Well, yeah, you should, because they're both exactly 3,000 above the mean, right? So if I'm looking for everything that's greater than something 3,000 away, that's the same answer as what's less than 12,000 or less, because it's symmetric. So we should have realized that to begin with, but either way, it's fine. Our answer is 0.0668. Same answer we had before. Okay? So first we had this number, 0668. Now we have this number, 0668. And you can even see that that's in fact going to happen, because if I plug in 12,000, which was the x value here, so if I plug in 12,000 here, and I plug in 18,000 here, and try to convert these to z-scores, I can do that by typing standardize. I need my value, which is this, not standardize, but standardize. I need my value, which is this. I need my mean, which is this. I need my standard deviation, which is that. Negative 1.5. And if I did the same thing here, value, mean, standard deviation, enter, positive 1.5. And remember, with the normal distribution, the area that's less than z, a negative z, is the same area that's greater than a positive z. So that's not surprising that we got the same answer. Okay. The last part of this question is question I have here, which was, how about between 13,000 and 17,000 hours? I'll get rid of this. And I'll just do it a little bit different just to show you what you could say. Probability that 13,000 is less than x, which is less than 17,000, equals, Norm dist, 17,000, because that's the bigger number. 15,000. 2,000. True. That's everything that's less than it, minus norm dist, 13,000. 15,000. 13,000. 15,000. 2,000. And true. Equals something. Okay. So I'm going to take this right here, copy it, come back here, type it in here just so you can see what it looks like, paste it back here, shrink these both to 16, and put equal signs in front of this one here so I can get an answer. And it never likes it when I do it that way. So I will actually oblige them. Take that off. Cut. It likes that. And then I put this one back in there. It likes that. And then I just subtract the two. So my computer's wishy-washy today. It doesn't like it combined, but it should. The answer is 6827. Okay. So we go back here, and I have 6827. Okay, well that's enough for this one video. I have several more to go. But you'll see in the next set of videos, I'll do some additional normal distribution problems. I'll still be using technology, but they're not as straightforward as the ones we were doing earlier today, earlier this week and in this video. And the reason why I'm showing you those is so you can get a full example of how you can use this information and not just have an idea of, plug in, get a number, okay, what's the use? Okay, so that's it for me. I don't really need that one right now. And I will talk to you guys soon. Take care.